All right, welcome back, everyone. Ready for another deep dive?
Always ready to dive in.
Awesome. Well, today we're tackling neural networks,
Oh, cool.
specifically how they learn,
Right.
especially these large language models we keep hearing about.
Yeah, they're everywhere now.
Seriously.
I know.
And you know what's really helpful for understanding this stuff? Visuals.
Well, absolutely.
So you sent over some research excerpts and even a few diagrams, which is fantastic.
Visuals can make all the difference with complex topics.
Totally. So let's start with the basics. How do you teach a neural network?
Well, it's not like traditional teaching, right?
Right. They're not sitting in a classroom.
No, it's more about guiding them to recognize patterns.
Okay, patterns in data. Got it.
Yeah, and it's not just about feeding them information blindly.
So there's more to it.
It's about emphasizing which patterns are important.
And that's where these visuals come in.
Exactly. Like those diagrams you sent.
The ones with the square wave graphs.
Yes. Each graph technically fits the data,
I noticed that.
but the neural network interprets each one differently.
Yeah, that surprised me.
It shows how nuanced the process is.
So it's not just a straightforward thing.
It's more like sculpting, you know.
Sculpting. Interesting analogy.
You start with raw material, like a block of marble,
Okay, I'm following.
and you shape it, revealing the form within.
So training a neural network is like that.
You're shaping its understanding by emphasizing certain patterns.
Interesting. So we're making decisions about which patterns matter most.
Absolutely. It's not purely mechanical.
There's a human element to it,
Definitely. Lots of choices involved.
like choosing the data it learns from.
Exactly. And the network's architecture.
And that brings us to loss functions.
Yes, and this visualization called a loss landscape.
Okay, now we're getting a little technical.
Oh.
Can you break those down for me? What are we talking about here with loss?
Well, imagine a huge mountainous terrain.
Okay, I'm picturing it.
That's your loss landscape.
Each point on this landscape represents.
How well the neural network is performing.
So lower point means.
Better performance. More accurate output.
So the goal is to find the lowest point.
Exactly. Like getting to the bottom of a valley
And how do we do that?
by adjusting the weights of the network.
Weights. What are those exactly?
They're like numerical values.
Okay,
They determine how the network processes information.
got it.
So adjusting them is like taking different paths down the mountain.
Trying to find the fastest way down.
You got it.
So we're giving the network directions.
In a way, yes. But the cool part is
What's the cool part?
there are sophisticated algorithms that help it learn.
So it's not just blindly following our directions.
It's learning from its mistakes, adjusting its path.
Makes sense.
Yeah.
This is making the training idea a lot clearer.
It's not abstract. It's like guiding it through a landscape.
But it's not just finding a single path, right?
You're right, there are challenges.
Like what?
Well, one of the most interesting is computational irreducibility.
Computational what now?
Yeah, it's a mouthful.
Can you explain that? It sounds intense.
Basically, it means some processes can't be shortcutted.
Even if we understand the rules.
Even then, you have to
Okay.
go through every step to see the result.
Huh. So even with all the computing power we have,
Sometimes you just can't skip ahead.
are there real-world consequences to this?
Oh, absolutely. Think about predicting a complex AI's behavior.
Okay, yeah.
Even if we know the rules and the data,
We can't fully predict its actions.
we might not be able to without actually running it and observing.
So even if we build these things, we don't necessarily have complete control.
That's definitely something to think about, and we can dive deeper into that later.
Yeah, let's do that. But first, I want to talk about how neural networks learn from examples.
Oh, great transition. That's how we learn, right?
Exactly. We learn language by listening and reading.
Immersion.
Right. We don't need someone to explain every grammar rule.
Do neural networks operate the same way?
Are they starting to?
They are. It's a big shift from earlier designs.
So older networks needed what?
Carefully engineered features.
Like,
Specific visual cues in an image, for example.
and modern networks.
They can learn directly from raw data, like we do.
So like ChatGPT,
Exactly.
with its almost spooky ability to sound human.
All thanks to being exposed to tons of text data.
So it's not just mimicking, it's developing an understanding,
That's a great way to put it.
even if it's a different kind of understanding than ours.
Exactly. And this ability to learn from raw data
It's driving progress in areas like natural language processing.
and image recognition and so much more.
It's mind-blowing how far we've come.
It really is.
But with this whole computational irreducibility thing,
Right.
are there limits to what they can learn? Can they truly learn anything?
That's the big question, isn't it?
It is.
And the answer is complicated.
Oh, boy.
Computational irreducibility does suggest limits to how much we can shortcut things.
Right.
But we're always finding new ways to optimize algorithms.
And designing better hardware.
Exactly.
So it's a race.
Kind of. We're trying to outrun those limits with technology
And we're pushing the boundaries of what we understand about computation.
and about intelligence itself. Who knows, maybe we'll discover entirely new ways of computing.
That completely sidestepped these limitations.
And that would be revolutionary.
Okay, let's get practical for a second.
Sure.
What does the future of neural network training look like?
Well, right now, we're training them on huge data sets.
Using powerful GPUs.
Yes, but there's a growing awareness that this brute force approach might not be sustainable.
So we're hitting a wall.
It's a concern, but also an opportunity
An opportunity for.
to get creative.
Okay, how?
The research suggests future hardware could allow for more efficient training,
More efficient. Like how?
perhaps even mimicking the human brain.
Whoa, that sounds futuristic.
It's still early, but there's research into neuromorphic computing,
Meaning?
hardware that operates more like biological neurons and synapses.
Instead of simulating neural networks on regular computers.
Exactly. We'd have hardware specifically built for this kind of processing,
That could be a game changer.
like when we move from calculators to the computers we have today,
A huge leap forward.
potentially.
But even with all that, this computational irreducibility issue,
It's still there, yeah.
does that mean there will always be limits to what neural networks can achieve?
It's a question researchers are wrestling with.
So, no easy answer.
Not really. On one hand, we have these inherent limits,
Right.
but our understanding of computation and intelligence, it's always evolving.
So we could discover breakthroughs that change everything.
Absolutely. And that's what makes this field so exciting.
It's not just about building smarter machines.
It's about expanding what we know about computation.
And about intelligence itself.
Exactly. It makes you rethink how we even define intelligence.
Right. If neural networks can do so much with an approach so different from traditional computing,
What does that say about our own brains?
and how we learn,
It's a profound question.
it really is. We've viewed intelligence through the lens of logic and reasoning for so long.
But neural networks suggest maybe there are other paths.
Paths based on pattern recognition, maybe?
Intuition, emergent behavior.
So maybe our definition of thinking needs to change.
It's not just about following rules
Maybe it's about recognizing patterns and making connections.
in ways we don't fully understand yet.
That's a huge shift in perspective.
It is. Neural networks challenge us to move beyond a human-centered view of intelligence,
Maybe intelligence comes in many forms.
each with its own strengths and limitations.
This makes me think about all those sci-fi stories about alien intelligence.
Right. Maybe they're not so far-fetched after all.
And that open-mindedness is crucial.
It is. By exploring these artificial systems,
We might learn secrets about our own minds.
we might even discover new forms of intelligence.
Ones we haven't even imagined yet.
That's the beauty of it.
This deep dive has taken us on quite a journey.
It has.
Yeah.
We started with the mechanics of neural networks.
And now we're contemplating the essence of intelligence itself.
We've covered a lot.
Our listeners' minds must be buzzing right now.
I bet.
What's one final thought you want to leave them with?
Well, if neural networks can achieve so much with this different approach to computing,
Makes you wonder.
are there other forms of computation out there?
Ones we haven't even discovered yet.
Exactly. Maybe we're just scratching the surface.
Of what's possible with computation and intelligence.
It's exciting thought.
It's a great point to end on.
I think so.
This deep dive has opened up more questions than answers.
But that's a good thing.
It has. It's ignited our curiosity.
And given us a glimpse of a future full of possibilities.
Exactly. So, to our listeners,
Keep exploring.
keep questioning.
Keep pushing the boundaries.
Who knows? Maybe one of you will make the next big AI breakthrough.
It could happen.
Until next time, keep diving deep. It processed all that text,
Mountains of it.
and it learned the patterns of human language.
The nuances of grammar, style, even how we use words to convey meaning.
Wow. So it's not just mimicking.
No, it's actually
Yeah.
developing an understanding.
Even if it's different from how we understand things.
Right. And this ability to learn from raw data,
It's driving progress in all sorts of areas.
like natural language processing and image recognition.
It's incredible, but I have to wonder, with this computational irreducibility,
Yeah.
are there limits to what these networks can learn?
That is the million-dollar question.
It really is.
It's true that computational irreducibility suggests we can't just shortcut everything.
Right.
But remember, we're constantly discovering new ways to optimize algorithms.
And we're designing more efficient hardware.
Exactly.
So it's a bit of a race then.
You could say that. We're trying to outrun those limits.
By using better technology.
In a way, yes,
Yeah.
but it's also about pushing the boundaries of what we understand.
About computation and intelligence itself.
Who knows? Maybe we'll find entirely new ways of computing.
Ones that completely change the game. That would be incredible. But let's get back to the practical side of things for a moment.
Okay.
What does the future of neural network training look like? Will we hit a wall with our current methods?
That's a good question. Your source material hinted at some pretty interesting possibilities.
Oh, like what?
Well, right now, we train most neural networks on massive data sets.
Using super powerful GPUs.
Right. But there's a growing awareness that this approach, this brute force method,
It might not be sustainable.
is a valid concern.
So we might reach the limits of what's possible with our current tools.
It's possible, but it also presents an opportunity
An opportunity.
to think outside the box.
Okay, I like that, but how?
The research suggests that future hardware advancements, they might allow for more efficient training methods,
More efficient?
perhaps even methods that mimic how the human brain learns.
Whoa, hold on. Mimicking the human brain, that sounds like science fiction.
It does, doesn't it? But there are researchers exploring something called neuromorphic computing.
Neuromorphic computing.
It's basically, imagine hardware designed to operate more like biological neurons.
Like the ones in our brains.
Yes. And synapses, too.
So instead of just simulating neural networks on traditional computers,
We'd have hardware specifically designed for it.
that would be a game changer, wouldn't it?
It could be. Think about the leap we made from basic calculators.
To the powerful computers we have today.
Exactly.
That's a pretty compelling argument. But even with these potential advancements,
Yeah.
this issue of computational irreducibility, it still hangs over everything, doesn't it?
It does.
So does that mean there will always be limits to what neural networks can achieve?
No matter how sophisticated they become.
Yeah, is there a ceiling?
It's a question a lot of researchers are grappling with.
So there's no easy answer
Not really. Computational irreducibility does suggest inherent limits.
to how much we can shortcut certain processes.
Exactly. But our understanding of computation and intelligence, it's always changing.
So maybe those limits aren't as fixed as they seem.
Exactly. We could discover breakthroughs that change our entire understanding.
Wow. You know, this whole conversation is making me rethink how we define intelligence.
In what way?
Well, if neural networks can accomplish so much with an approach that's so different from traditional computing,
What does that tell us about our own brains?
right? What does it tell us about how we learn and think?
It's a deep question.
It is. For centuries, we've viewed intelligence through the lens of logic.
Reasoning, deduction.
But neural networks suggest maybe there are other ways of being intelligent.
Other paths.
Yeah, paths based on pattern recognition, intuition, emergent behavior, things like that.
So maybe our definition of thinking is too narrow.
Maybe. It might not just be about following a set of rules.
It could be about recognizing patterns and making connections.
In ways that we don't even fully comprehend yet.
That's a fascinating thought.
It is. And neural networks. They challenge us to move beyond a human-centered view of intelligence.
Meaning?
Maybe intelligence doesn't have to look like us.
Oh, I see.
Maybe it comes in many forms, each with its own strengths and limitations.
That's a powerful idea.
I think so too. It's a real shift in perspective.
It is. It makes me think about all those sci-fi stories about alien intelligence.
Right. Maybe they're not so far-fetched after all.
And that open-mindedness.
It's crucial.
It is. By exploring these artificial systems.
We might learn things about ourselves that we never expected.
And who knows? We might even discover entirely new forms of intelligence.
Ones we haven't even begun to imagine.
The possibilities are endless. It's like we're holding up a mirror
Using AI to understand ourselves better.
and questioning our own assumptions.
It's kind of humbling, isn't it?
It is. But it's also super exciting. Some scientists are studying how neural networks and biological brains learn.
Trying to find common ground.
Yeah. To unlock the fundamental principles of intelligence.
Makes sense. If we can figure out what makes these systems tick.
We might learn something new about how we learn and think.
Exactly. It's a reminder that this whole quest,
It's not just scientific.
it's deeply human.
It's about figuring out who we are and where we fit in.
This deep dive has really taken us on a journey.
We started with the nuts and bolts of neural networks.
And now we're pondering the nature of intelligence itself.
It's a testament to how thought-provoking these topics are.
I bet our listeners are feeling it too.
Their minds must be buzzing.
Before we wrap up, what's one last thought you want to leave everyone with?
Well, if neural networks can achieve so much with an approach so different from traditional computing,
That makes you wonder.
are there other forms of computation out there beyond what we currently understand?
That could revolutionize AI.
Maybe even our understanding of intelligence itself.
That's a great note to end on.
I think so too.
It seems like this deep dive has opened up more questions than answers.
But that's the beauty of it, right?
It sparked our curiosity.
And given us a glimpse of what might be possible.
To our listeners, keep exploring, keep questioning.
Keep pushing the boundaries.
Who knows? Maybe one of you will be the one to make the next big AI breakthrough.
We can't wait to see what the future holds.
Until next time, keep diving deep.